Beyond the blue giant, a new frontier. Our solar system is a vast and mysterious place. It is a cosmic neighborhood filled with wonders and secrets waiting to be discovered. From the blazing sun at its heart, to the icy edges of the Kuiper Belt, each celestial body tells a story of cosmic evolution. We've sent probes to the scorching surface of Venus, a planet shrouded in thick clouds of sulfuric acid, where temperatures soar high enough to melt lead, and rovers to explore the dusty plains of Mars, searching for signs of ancient life and studying its geology to understand its past. But what lies beyond the gas giant Neptune? This distant world marks the boundary of our known solar system, a gateway to the unknown. What secrets are hidden in the cold, dark depths of our solar system's outer reaches? These regions are shrouded in mystery, with only a few distant stars to light the way. Beyond Neptune, we enter a realm of icy bodies and cosmic debris, a region known as the Kuiper Belt. This area is teeming with ancient objects that have remained largely unchanged since the solar system's formation. This ring of icy objects is a remnant from the early solar system, a cosmic fossil that holds clues to the formation of our planetary neighborhood. Studying these objects can provide insights into the processes that shaped our solar system. Even further out, extending almost halfway to the nearest star, lies the Oort Cloud. This distant region is a vast spherical shell of icy bodies that surrounds our solar system. This hypothetical sphere of icy objects is believed to be the source of long-period comets, those icy wanderers that grace our skies with their spectacular tails. These comets can take thousands of years to complete an orbit around the Sun. Join me as we venture beyond the familiar planets and explore these uncharted territories. Together, we will journey into the unknown, seeking to uncover the secrets that lie beyond the edge of our solar system. Let's uncover the secrets of the Kuiper Belt and the Oort Cloud, regions that hold the key to understanding the history and evolution of our solar system, and unravel the mysteries of our cosmic origin story. By studying these distant regions, we can piece together the puzzle of how our solar system came to be and what it might look like in the future. The Kuiper Belt, a disk of icy secrets. Imagine a giant disk of icy objects, remnants from the formation of our solar system. This is the Kuiper Belt, a region extending from Neptune's orbit at about 30 astronomical units to approximately 50 astronomical units from the Sun. Unlike the inner solar system, where rocky planets and asteroid belts reside, the Kuiper Belt is a realm of ice. It's a cosmic graveyard of sorts, where leftover building blocks from the early solar system have been preserved for billions of years. These icy objects, composed of frozen water, methane and ammonia, hold clues to the conditions under which our solar system formed. Studying them can provide insights into the chemical makeup of the primordial nebula from which our sun and planets were born. Pluto and its kin dwarfs of the outer solar system. Pluto, once considered our ninth planet, is the most famous resident of the Kuiper Belt. But Pluto is not alone. It's now recognized as a dwarf planet, one of many icy worlds orbiting the Sun in this distant region. Other dwarf planets in the Kuiper Belt include Eris, Haumea, and Makemake. Each of these worlds has its own unique characteristics and composition, offering a diverse array of objects for scientists to study. These dwarf planets are like miniature planets with their own moons and geological features. They provide a fascinating glimpse into the diversity of objects that can exist in our solar system. The Oort Cloud, a distant halo of mysteries. Far beyond the Kuiper Belt, stretching out almost halfway to the nearest star, lies the Oort Cloud. This enigmatic region is a boundary of our solar system, a frontier that remains largely unexplored and shrouded in mystery. This vast spherical halo of icy objects is so distant that we haven't observed it directly. Instead, its presence is a hypothesis, supported by indirect evidence and mathematical models. Its existence is inferred from the long-period comets that occasionally visit the inner solar system. These comets, with their elongated orbits, suggest a distant origin far beyond the planets we are familiar with. Unlike Kuiper Belt objects, which orbit in a relatively flat plane, Oort Cloud objects are thought to have randomly inclined orbits, forming a spherical shell around the Sun. This randomness in their paths hints at a chaotic past influenced by the gravitational forces of nearby stars and the giant planets. This difference in orbital characteristics suggests different origins for these two distant regions. While the Kuiper Belt is believed to be a remnant of the primordial disk from which the solar system formed, The Oort Cloud's objects might have been scattered outward during the early, tumultuous years of the solar system's formation. The Oort Cloud is believed to be a reservoir of icy planetesimals, remnants from the early solar system that were scattered outward by the gravitational influence of the giant planets. These ancient objects are like time capsules preserving the conditions of the early solar system. These icy bodies remain in a state of suspended animation, only occasionally nudged towards the sun to become long-period comets. When they do, they offer us a rare glimpse into the distant past, carrying with them secrets from the dawn of our solar system. Section 5: Cosmic Messengers, Long-Period Comets and Their Origins. Long-period comets with orbital periods of hundreds or even thousands of years are thought to originate from the Oort Cloud. These icy wanderers are like cosmic messengers carrying pristine material from the outer reaches of the solar system. As a comet approaches the sun, it heats up, and its icy volatiles sublimate, forming a glowing coma and often spectacular tails. This outgassing releases gas and dust that can be analyzed to reveal the chemical composition of the comet's nucleus. By studying these cosmic messengers, we gain insights into the conditions and composition of the early solar system. Long-period comets offer a unique opportunity to study materials that have remained virtually unchanged since the birth of our planetary system. Section 6: Echoes of Creation, Unveiling the Solar System's Past. The Kuiper Belt and the Oort Cloud are like time capsules, preserving remnants from the early solar system. By studying these distant regions, we can piece together the story of our solar system's formation and evolution. The composition and distribution of objects in these regions provide clues about the processes that shaped our planetary neighborhood. They offer insights into the dynamics of the early solar system, the role of giant planet migration, and the conditions under which planets formed. Understanding the formation and evolution of our own solar system gives us a framework for understanding the formation of planetary systems around other stars. It allows us to place our own solar system in a broader cosmic context. Section 7: New Horizons and Beyond, Pioneering Missions to the Outer Reaches. Exploring the Kuiper Belt and the Oort Cloud presents significant technical challenges due to the vast distances and faintness of the objects. However, space agencies like NASA are developing missions to explore these uncharted territories. NASA's New Horizons spacecraft, after its historic flyby of Pluto in 2015, continued on its journey into the Kuiper Belt. It performed a close flyby of a smaller Kuiper Belt object called Arrokoth, formerly Ultima Thule, in 2019, providing our first close-up views of one of these primordial objects. Future missions are being considered to study other Kuiper Belt objects in more detail, and even to search for evidence of the elusive Oort Cloud. These missions will rely on advanced technologies and innovative techniques to overcome the challenges of exploring these distant realms. Section 8: The Uncharted Territories, Mysteries Yet to be Unveiled. The Kuiper Belt and the Oort Cloud are vast and largely unexplored regions, holding countless mysteries yet to be unveiled. What is the true extent and distribution of objects in the Oort Cloud? Are there undiscovered dwarf planets or even larger objects lurking in these distant realms? What can the composition of Kuiper Belt objects tell us about the early solar system and the conditions under which life arose on Earth? Can we find evidence of past collisions or other dynamic events that shaped these outer regions? The answers to these questions and many more await further exploration. As we continue to probe the outer reaches of our solar system, we are sure to make new and exciting discoveries that will deepen our understanding of our cosmic origins. Section 9: A Universe of Wonder, Our Place in the Cosmic Tapestry. The exploration of the Kuiper Belt and the Oort Cloud reminds us of the vastness and wonder of the universe we inhabit. These distant regions filled with icy bodies and comets are like time capsules preserving the early history of our solar system. They offer clues about the primordial materials that coalesce to form the planets and moons we see today. It highlights our place within the grand cosmic tapestry, a tapestry woven from the remnants of ancient stars and the endless dance of gravity. Each star, each planet, and each comet is a thread in this intricate fabric, telling a story of creation, destruction, and rebirth. As we delve deeper into the mysteries of our solar system's outer reaches, we gain a greater appreciation for the processes that led to the formation of our planet and the emergence of life. The study of these distant objects not only informs us about our past, but also inspires us to ponder the future of our cosmic journey. We are reminded that we are part of something much larger than ourselves. A cosmic story that spans billions of years and stretches across unimaginable distances. The light from distant stars that we see today began its journey long before life on Earth even existed, connecting us to the ancient past. Let us continue to explore, to question, and to marvel at the wonders of the cosmos. Each discovery, each new piece of knowledge brings us closer to understanding our place in the universe and the nature of existence itself. For in the words of Carl Sagan, somewhere, something incredible is waiting to be known, and it is through our relentless curiosity and unyielding quest for knowledge that we will uncover these incredible truths.